Good evening all, welcome to today's session. We'll wait for a couple of minutes for a few more students to join and then we'll get started. So we'll quickly get started. So I have displayed my problems. Hope my screen is visible. So you can go through the problem. I'll wait for you can take around 5 minutes and then we'll start discussing the solution as well. Hi, good evening. We'll wait for a few more minutes. So in the meantime, you can go through the question and attempt to solve yourself. And then we'll discuss the solutions. Maybe I'll give you maybe 5 minutes. So you should be able to solve it in a couple of minutes and then we'll discuss. So I've seen some new students from the last week. Just to give an introduction of myself, so I'm Durga Prasad. So I'm doing PhD currently in IIT Madras. So I'll be the TA for this particular session. So the main objective of this session is to help you solve your assignment problems, and then we can also discuss any other doubts that you had during when you went through the lecture videos. So objective of this session is to help to clarify your doubts. So if you do not have any doubts, then we can solve some problems also. So feel free to unmute yourself, or you can also type in the chat box. That's up to you. I think we can get started. It's around already 5 minutes past 5. Okay, the first problem is essentially a very simple one. So we have a cylinder, and then CO2 is being let into the cylinder. Initially, the amount of gas present is 15 kilograms, and the volume is also specified to you. Initial pressure is also specified to be around 10 bar. Now, you kind of added another 15 kg of CO2 gas to that particular cylinder. After a certain time, certain hole developed, and because of that hole, mass is leaking from the cylinder. Now there are two parts of it. The first part asks you to find the specific volume. Specific volume before adding carbon dioxide and after adding the carbon dioxide. So I think this is straightforward. So how do I calculate the specific volume? Okay, maybe let me ask in a slightly different word. The first part is straightforward, I guess. So specific volume is defined as the total amount of volume divided by the total mass. So initially the volume is specified to be 20 meter cube, and then the mass of gas present is 15 kg. Initially, after the gas is added, the mass is changed to 30. So specific volume for the initial and the final states are known. Now coming to the second part of the question. So it asks you that as the gas is leaking, can you draw a plot of the specific volume versus the mass, basically mass versus the specific volume. So how would that look? So you can maybe tell the expression of it or type it in the chat box. So we will do the plotting little later. Okay, first of all, is the question clear, or are there any difficulty in the question? Like, is the wording clear, or are there any ambiguous sentences or something like that? The first part is straightforward, so I am not taking much time on that. So you just calculate the volume divided by mass, so it is straightforward. So now for the second part, how will I plot that particular graph? If M escape is the mass of the gas that is escaped from the cylinder, then the remaining mass will be initial mass minus escape mass. So the specific volume will be given by this particular expression. And I am asking you to plot this versus the new versus the mass escaped. It goes something like this. So on the y-axis is my specific volume, and on the x-axis is the mass that is escaped. So initially it is around 0.67, and then as the mass is keep on escaping, it ranged up to 1, and then it will keep on increasing. So this is straightforward. Now let me ask the question. When the mass is escaping, so what happens to the pressure inside the cylinder? So what happens to the pressure inside the cylinder? Can one of you type the answer in the chat box, or you can unmute yourself? So we know that as the mass is escaping, the specific volume will keep on increasing because volume is held constant. So what can I say about the pressure inside the cylinder? Okay. So can I say the pressure increases inside the cylinder, or anything about? In order to say anything about the pressure, first I need to know that particular process in which the phenomenon is happening. So as we discussed in the last week also, whenever you want to kind of identify these kind of things, you need to know what is the boundary, what is happening at the boundaries as well. So what is the system that I am considering here? If the mass is continuously escaping from the cylinder, what will be the system that I will consider? Decrease. Okay, you say pressure decreases. Okay, I think others are not there. So let me put it in a slightly different way. So how do you kind of ensure that how do you assume that the pressure will decrease, or how do you come to the conclusion that pressure will decrease? Yes. Yeah, you're audible.
Actually, I asking some doubts because this is my first session, sir. I joined your class.
Okay.
Can you suggest me, sir? This course also help for my GATE exam. Actually, I am also preparing for GATE exam. I am chemical engineering, sir.
Chemical. Okay. Okay.
And also I am from Bihar, sir. But I understand whatever it is. Can you explain sometimes in Hindi, sir?
Not that fluent in Hindi.
Where are you from, sir?
But it doesn't matter, the location doesn't matter, but the video is actually recorded, so it would be better if I teach in English itself.
Okay, sir. So how can you suggest me
So
how
my,
to prepare for GATE exam for chemical engineering?
I'm actually from mechanical background, so I haven't actually had the chance to see any chemical papers.
But any have idea, sir? Any books?
No, I cannot, like I haven't seen the paper, so I cannot say anything on that. So that would be kind of misleading you if I say something. But from the conceptual wise, if you have any queries, you can ask me related to this particular topic. But as far as the GATE paper is concerned, I haven't seen the paper, so I cannot comment anything on that.
Okay, sir. Hello, one thing, sir. Hello.
Yes.
Sir, here I got from the previous classes all questions and papers inclusive.
Question papers for?
Sir, already assignment 1 is problem already exists, sir. Assignment big assignment 1, sir. Solution. Whatever we teach previous classes, here I got from that question.
So, okay, so you were asking about the assignments during the live sessions or in the course? If it was the course, then the solutions will be provided later, not now. So after the deadline is completed. If you are discussing about our
Yes, sir. previous classes, week assignment 1, sir.
So for week assignment 1 for the session that I conducted or the ones like there are 2 sessions now. So which one you are referring to? The one that I conducted?
Actually, I am telling to you, sir. Actually, already you teach, na, sir. Assignment first week already you teach na the GMAT class. Like same similarly this type of session already you teach now.
That ones are already uploaded on the Google Drive link that will be provided to you. So there is, if you
I didn't get every course I got the email, but I see only to release now is also release the third assignment. But I got the every course email, I check Google Drive sheet, but I didn't get the thumbnails in the assignment 1 session, whatever you teach in the class, this recording class. I didn't get it, sir.
So
Uploaded, sir.
no, it's already uploaded. So in the course, like there is a week 0, week 1, week 2, week 3, right? Below that there is a problem solving session. There's a tab for that.
You have the below, sir.
1 second. I'll just show you once. So my screen is visible, right?
Yes, sir.
So there is something called problem solving session here.
Yes.
So you go over there. So you just click on that. So you'll get access to this one. So here you have one is a recorded lecture and the second is a Google Drive link.
Okay, sir. Click here after I got it.
Yeah. So here I will upload all the weekly ones.
Thank you, sir. Thank you so much.
Okay. Yeah, now coming back to this particular question. So just like what we discussed in the last week, the pressure will not directly, like you will not be able to comment directly on the pressure because you do not know the nature of heat interaction. Like in this particular question, nothing is specified about what happens at the boundaries for the heat problem. Like is it adiabatic or isothermal or something of that sort has to be provided. Only then you will know what to do with the Q. Only then you should be able to say what will happen to the final pressure. So without specifying the particular process, you should be saying that the information is insufficient. I hope that is clear. Now we'll go to the next problem. Yeah, maybe it'll take a couple of minutes and then you can solve it yourself and then we'll discuss. You need to just tell me what is the final absolute pressure inside the chamber.
This type of concept I didn't study, so that's
okay, then maybe I'll kind of give you a brief idea of what it is. So for the second problem, the idea is you have okay, a vacuum gauge is an instrument that measures pressure. 1 second, there is someone wants to join. Okay, so it measures pressure. So what it says is you have this instrument put inside a chamber. So there is a big chamber and then you have this gauge kept inside the chamber and the gauge is giving a value of around 0.2 bar. Now whenever they say where there is a gauge pressure, it means it is the difference between two different pressures. There is something called absolute pressure and something called gauge pressure. Gauge pressure is basically the pressure difference between two different entities. So if you recollect your YouTube manometer, so even in YouTube manometer you will have a U-shaped thing with one end, like the difference in the heights of the mercury columns in both the tubes will give you the pressure difference. So there also you will only get the gauge pressure between these 2 points. Here it's the same thing. So the only difference is here we are indirectly telling you that it is the pressure is equivalent to 750 mm of a column of mercury, and we have provided the density and acceleration due to gravity. So the question asks you to find the absolute pressure. So before even solving that, first thing you need to know is how is pressure related to density, acceleration due to gravity, like how is pressure related to this mercury column. So if you recollect your hydrostatic pressure, how is hydrostatic pressure defined? So if you have some container like this and then you have a liquid inside the container, let's say this is the level up to which liquid is filled, then if you consider a control volume or if you consider a small block inside this, on this fluid element there will be forces from all the directions that will be balanced, that fluid element is at rest, which means the net force on that should be balanced from the top and bottom. So if you apply that energy balance, the net force on this will be equal to the pressure that this particular fluid element will be experiencing is what we are calling hydrostatic pressure. And what is that pressure? That pressure will be proportional to the total whatever fluid is on top of that element. So this entire thing, the weight of the entire thing is being felt by this element. So that will be my hydrostatic pressure. So if I consider at this bottom point, the total pressure will be rho GH. So now we have, when we define a gauge pressure, it means that this pressure is with reference to some other point. So now in this figure, when I have shown it as a closed tube, the pressure on the, we have considered only the weight of the fluid on top of this one, and we assumed that whatever is in this other part, other half of it is nothing. But it can happen that there is some other fluid here also. When something like that happens, so basically you can think of it like having another fluid here. Maybe I'll use a different color. Something like this. You can have two different fluids. When you have something like this, and when I ask you to find the total pressure at this point, you have to consider the weight of this blue color one and then the top one also. Combined weight is what will give you the total hydrostatic pressure. So now when you have a U-tube manometer, so let's say you have, in this case when a gauge pressure is measured, so gauge pressure is defined in such a way that it will be with respect to some reference. Like in this example, the reference is with respect to the top level. So when you say the pressure at the bottom is rho g this side plus rho g this side, it means the pressure difference between this point A here somewhere on the top and point B somewhere on the bottom. The pressure difference between these 2 points is rho GH. So this is what we are calling gauge pressure. The reference is with respect to A. Let's say A is a reference point and P is a point at which I am measuring the gauge pressure. In this case, we are saying that the reference is with respect to atmospheric pressure. So with respect to atmospheric pressure, how is this related? So density is already provided, G is already provided, H is given in mm, so you just need to convert it into meter, and then atmospheric pressure you can calculate. The reference is given to be atmospheric pressure. And the next important part here is whenever you say gauge pressure, it is with respect to two different points. So pressure at point B can be higher than at point A, or it can be lower than that of at point A. So in this particular scenario, if A and B are interchanged, if the gauge pressure at, if I say something like PB, I can define it as PB gauge, which means pressure at point B with respect to A is say 10 Pascal. Then what will happen to PA gauge with respect to B? So that will be a negative value, right? So if B pressure is higher than the A pressure, then if you take B as your reference point, then if you want to measure at point A, that will be a negative pressure. So though the absolute value of pressure can never be negative, this gauge pressure can actually be negative. And whenever you have this negative value, then usually it doesn't feel good to write the negative before that, so you call it with a different name. So we call it vacuum. So in the question, if someone says you that a vacuum gauge, or they say something like this, they say that 0.25 bar, and then they mention that it is vacuum, which means the pressure is lesser than the reference pressure. That is the only main point that I want you to take from this particular question. Instead of taking the other way, the value that you get should be less than the atmospheric pressure. It's the only difference. Is it clear, or are there any questions?
Sir, how can should this atmospheric pressure equal to sir rho GH by 10,000 sir? Or sir 10 bar 5?
Yeah. So in the question here, they told that the pressure of the surrounding atmosphere is equivalent to 750 mm column of mercury, and so on and so on. So it is provided in the question itself that the atmospheric pressure can be taken as a hydrostatic pressure of 750 mm column mercury.
Yeah, and why the 10 also written one?
That 1000 in the denominator is just to take care of the unit. The height is unit. So 750 mm, right? That I converted into meter. Rho is in kg, like everything is in SI unit. So this entire thing will be in Pascal. But I'm just writing bar here. So to convert from Pascal to bar, I have to divide it with 10 power 5. Okay. Yes. Yes.
Sir, absolute pressure equal to pre-reference pressure minus pressure gain pressure.
See, so basically you can have two different scenarios. So P gauge, P gauge is actually P absolute minus P reference. So this is how you define the normal definition. But whenever I say it is a vacuum gauge, which means you are taking it the negative of it. So P gauge is actually negative value. So the P gauge here, I am just taking the direct value as it is. If you want to use still the same formula, then when you are substituting it, you have to ensure that P gauge you are substituting minus 0.2 equal to P absolute, whatever is the x that you want to find, minus P reference. You can do this way.
P reference equal to given 1 bar, sir. Where is given 1 bar?
P reference is atmospheric. So I'm just giving a number here. The reference is, if say atmospheric pressure is taken as 1 bar, then you will put that 1 bar here. Okay, but then the only thing you have to ensure is the P gauge you should take a negative of minus 0.2 instead of 0.2 bar. I'm taking P gauge to be positive value, so I change the formula here. Okay.
And one formula also there, sir. P absolute pressure equal to P absolute pressure plus P gain pressure.
Yeah, if you take this one, P absolute pressure is equals to P gauge plus P atmosphere reference pressure. Yes. So it's the same formula. Just because I did not put minus here, I changed this here.
According to taken the according to question, sir, I think.
Yes. According to question, you have to change it. So
what is indicate for the P reference pressure, sir?
So how to choose P reference depends on how your gauge is located. So if your pressure gauge is like if you are measuring between this A and B, so one end of the pressure gauge is connected to point B and other end is connected to point A, then you will choose one of them as a reference point. So basically your manometer will only, like this particular gauge pressure will tell you only PA minus PB. It's like it won't tell you which is what.
What is indicate for the top A and top B? Top A also at the what is indicated? So you can explain the modern difference, point A and point B.
So if this is your container, this is some fluid. Let's remove this particular fluid. So let's say you just have water like this, and then you, instead of being closed, let's say it is open to atmosphere. Like point A is open to atmosphere. So at point A it will be atmospheric pressure. At point B the pressure will be atmospheric pressure plus rho GH. So now what I do, I bring a new sensor. So I will connect one point of the sensor here, and then I will take another part of the sensor from point B, something like this. And whenever I connect these two sensors, I need to tell which part is plus part and which part is minus part. So basically the sensor will tell you, so let's say this part of the sensor is connected to the reference point, the other part will be your measuring point.
Okay.
So when you measure this sensor, like when you take readings with using some sensor, let's say you have some sensor here, when you take readings from that, it will only tell me PA minus PB. It won't tell me what PA is or what PB is. It will only tell me PA minus PB. Or sorry, in this case the reference is this side, so it will only tell me PB minus PA. It's like with respect to reference, how much excess is PB. That's the only value that it will tell me. It won't tell me anything else. Now I will take the same gauge pressure and then I will compare it with a known pressure value. So from there I will assess what the reference value is. So let's say the pressure gauge is already compared with the known pressure of, say, I already know what is atmospheric pressure. So what I will do is I will leave the other end to atmosphere always, so that I can calculate the absolute pressure directly. Okay. Next one is a bit lengthy question to read, so maybe you can go through the question once, and then we'll
I think so. This type of problem I go asking in GATE, sir. I think this types of problem.
Yeah, if you are solid with your fundamentals, then I think it should be easy to go through any exam.
Yeah, but these types of theory also available in all branches, think mechanical,
Yes.
chemical, and yeah, both of them, and also civil.
So we can go through the question first, and then we'll discuss.
Okay, sir, you can explain me, sir.
So have you solved it already?
Not, sir, because these types of question I didn't study the topic, sir. That's a problem. You can teach, I understand, sir. Whatever
Okay, then maybe I'll explain you the concept and you try it yourself. That would be better. It's like anyways we are spending some time, so it's better you solve it yourself rather than me giving you the solution. Is that okay?
Okay, sir.
Okay. So what were you expected to find in this problem? So what are you trying to find? The question asks you to find the pressure of the air within the cylinder, right? When the piston is in its initial position. Okay. So how will I get the pressure here? Like where do you start? Pressure is basically what?
So equal to force by area, sir.
Yes. So how do I calculate the force there? So what is the net force acting on that air?
Force is given, sir. Force is given equal to 10 points, sir. And
That is spring constant.
oh, sorry, sir. Force is
Okay. Area you already know. Area is given directly.
area already given, sir. 7.8 into 10 to the
Yes.
power minus 3 meter square.
Area is given. So what is force?
Force is, I think so, sir. Force is equal to IMG. I can take the gravity force, sir.
Yeah, gravity weight is one force, and then
I can first of all I can find the value of pressure, force per area. Only area is given 7.10 minus 3
Yes.
meter square.
Hmm.
And also given the here, sir, mass equal to 10 kg.
Mass is given as 10 kg. Area is given. So the question asks you to find pressure in two different cases, in the initial case and the final case. So what is initial case and what is final case?
Yes, sir. Initial position, yes, sir. Determine the pressure of the within the cylinder part in the piston initial friction and within the piston the body pressure. Yes, sir.
So what is the initial position and what is the final position?
Okay, sir. I tried, but sir, some.
Let's just split the problem. So the first part is you need to understand it in the initial position. So what is initial position is when the valve is closed. So basically this is a scenario. So there is some air inside, but the valve is closed. It is not connected to the supply line. So the pressure here is, as you mentioned, that will be force by area. Now I need to calculate the total force acting on this one. So one is a weight force. What other forces are there other than weight force? So will the spring exert any force? Mg is a weight force. The next one is, will the spring exert any force initially?
Surface tension, sir.
No, let's not go into surface tension. I am asking about the spring. There is a spring here, right? Will the spring exert any force? So we will just see component by component. Now this is air. Air is in contact with what all things? Air is in contact with the walls, air is in contact with the piston. Now you told that the piston will exert weight force on the air. Now what that is one force. The next thing is piston is connected to two things. Piston is connected to the spring and piston is also exposed to atmosphere. So these two things will exert force on piston and then piston will exert the same force on the air. So I need to account for those two forces also, right?
Yeah.
Okay. Now what is a force that the spring will exert on the piston? So that is given in the question. So if you see here,
Longitudinal forces.
no, initially it is given, initially the bottom of the piston is at x equal to 0 and the spring exerts a negligible force on the piston.
Not for negligible force. So there spring or not any force in the force.
So initially the spring is not compressed, so you do not have any force, so that will be 0. So let's first talk about the initial case. So in the initial case you have force to be 0 from the piston. Okay, so we have considered weight force, spring is also considered, so what is left? So we have determined 3 or 4 things, right? The air is in contact with walls of the cylinder, piston, and piston is in contact with spring and atmospheric. So what about atmospheric pressure? So will atmospheric pressure exert any force on this? So you are there, right? Or am I audible?
Yes, sir.
Yeah. So did you consider the atmospheric pressure?
Pressure is equal to, sir.
So before even going there, so will atmospheric pressure contribute to the pressure inside the air? Like if we draw a free body diagram for this piston, only for the piston, what are the forces acting on the piston? Pressure from the air, weight of that piston is already there, spring force we have considered to be 0, and then there will be an atmospheric pressure. These are the only forces, right? So what is the force exerted by atmosphere on the piston? That will be the atmospheric pressure times the total area, right? So were you able to calculate the final value of it? So if you calculate, just let me know the value, we will compare it. So the pressure of air within the cylinder in bar when the piston is in its initial position. And then once you do for the initial position, the next part is also, the next part is basically asks you to find when the piston is in its final position, which means you open the valve and then air flows from here to here, and then what happens is this piston moves upward. So when the piston goes upward, it will compress the spring. So because of that compression, the spring will exert another force on the piston. So previously when the piston is at x equal to 0, you do not have any force from the spring. But now you will have another force from the spring given by this particular equation, k times x. You know the k value. So how do I calculate the x? So how do I know how much the piston will displace? If you can calculate that, then you can calculate the spring force. Then you already made the free body diagram for this. So all you have to do is add the weight plus the spring force plus the atmospheric pressure divided by total area will give you the pressure of air. So that is straightforward. So how will I get the x? How will I get the displacement? Okay, first system consideration, we have done that. So this is our system. Okay. So is this fine? Can I consider this as my system? Or you will object to it saying that when I open the valve, mass is coming into it, so I should not consider it as a system or something like that? Or is it okay? Is it okay to consider this as my system initially? So I'll solve the problem in two different cases. Initial case, I'll only consider this as my system. Again, I'll open the valve, gas flows inside, piston compresses and the flow stops. Then I'll consider again this air as a system, but then the piston will be displaced little upwards. So I'm considering system only at the initial state and the final state, not in between during the entire process. This is already given, we have already discussed this. So how to calculate the spring displacement? Is something provided in the question that can help me calculate the displacement of the spring? Maybe I should show the question for you then. Okay. So how do I calculate the displacement of the piston? So I can calculate the displacement from volume and area. So here it is already given that the volume is expanded, like it is causing the volume of air to increase by so and so value. So I know what is the delta V. So if I know delta V, how can I calculate displacement from there? From straightforward geometry, you can use, like, this is a cylinder, you know the face area, so you basically know this area. So area times displacement will give you the change in volume. So once I know the volume, I know the area, so I can calculate the displacement. So once I know displacement, I can substitute it here. I know the value of stiffness, so I can directly calculate the force. So basically we are assuming area to be constant, and then the delta V divided by area will give you the raise of the piston position. Once I know that, based on your free body diagram, you have the spring force. Okay, here comes the next question. Once you apply the free body diagram, all you can say is the net force acting on the piston is weight plus kx plus atmospheric pressure minus air pressure. But here I have two unknowns. I need to determine the air pressure, and I also don't know the left hand side of the equation, which is the force on the piston. So two unknowns in one equation. So how will I solve it? My objective is to find PA, but I don't know the piston, the force on net force on the piston also. So how will I solve that? I need one more equation. So what is that one additional equation that will help me solve this problem? I don't want to spend much time on this week. We'll discuss this even in the next week lectures also. We discuss something called quasi-equilibrium state. So essentially we will assume that the process is so slow, that is happening very slowly, that the piston is moving very slow, and you can consider the acceleration of the piston to be 0. So if you consider that, then this force on the piston is mass times acceleration, so acceleration will be 0. So the force will be 0. So once you substitute F equal to 0, you will be able to solve this directly, and then you can directly get the expression. I didn't write the value here, but you can calculate it. That's straightforward. You know all the values of mass of the piston is given, K is known, X is known, so all the values are there. So all you have to do is just substitute, and then you'll be able to find that. So are there any questions, or is it clear?
Yes, sir.
Okay, so we'll go to the next problem. I just kept this problem because last week we discussed on something like a linear case where you have a resistance based thermometer, but then the resistance is varying linearly with temperature. But not all materials will follow the same kind of relation. There could be materials which follow something like this. So this is the example of a thermistor. So here they don't vary linearly, but then they follow this particular relation where resistance is varying in terms of some other relation. So here also, if you see, all you need to determine is you need a calibration point for sure, and then this beta is the material property. Like in case of linear expansion, you have alpha, thermal coefficient of expansion, you have beta here. That's the only difference. Other than that, here also you would be requiring two constants, R0 and T0, which is same as the previous case. Even in case of linear, when we discussed last week, we have an R0 and we have a T0. The only difference between that and this is non-linear, that is a linear case. So if this is in this problem, the question gives you the values of R0, T0, and then it also does a calibration test. So it gives you at some particular point, at say 422 Kelvin, the resistance is given to be so and so value. So all it did is it took two different temperatures, one at 310 Kelvin, the other one at 422 Kelvin. Using these two temperatures, they calculate the resistance. From there, you should be able to find the value of beta. Once you know the beta value, then whenever you use this thermistor at a new temperature, you will calculate the resistance, and then you can back calculate this one. So this is straightforward mathematical equation. So maybe I'll just give you maybe 2 minutes, so you can just solve me and tell the value of beta for this particular case, just as a warm up, so that before going to some discussions, the next question is more of a discussion oriented one. And if you are planning to take exams, you might expect some numerical questions as well, not the subjective one. So you can quickly solve this one. Maybe 2 minutes, you can solve this and tell me what's the value of beta that you are getting. If there is any doubt in the question, you can ask me. Just to kind of have some discussion, do you think will there be any advantage in using this non-linear ones instead of linear ones, or is there any advantage in using only linear ones, or doesn't matter? So if I am using thermistor versus the last case, in the last session we discussed on a resistance based thermometer, that is just like a resistor whose resistance value changes with temperature in a linear fashion. This is changing exponentially. So do you think will there be any advantage with this one or the other one, or it doesn't matter, both are just the same? You can just type or just unmute and say what you think about it. I just want to have some interaction. So I think you would have solved. So what is the value of beta that you get here? I don't want to spend much time on this since this is more of a math problem. So all you have to do is substitute the value of r naught, t and t naught that is given in the question. Then just a little rearrangement, you should be able to find the value of beta. So I just plotted this just to show you that it is not linear. It has some non-linearity, but if you observe closely, there will be certain regions where it will actually be linear, in the sense that you can approximate it to be a linear one, even though the original function is a non-linear form. At high temperatures, you can assume that it will be close to linear. And coming back to our question, as long as you know how it varies, it doesn't matter to you. The only difference comes with the sensitivity. We will discuss this in the next problem. So this is something like you might have seen a YouTube manometer. So you have a U-shaped thing. You have two different levels of mercury in it, and the difference in these levels will give you the difference between the pressure at the open ends of the manometer. Now we can also have an inclined manometer, something like this. So the question asks you to find you need to find the pressure here. Let's say I tell you the height of this column from, say, this reference point is h. So what will be the pressure here at this particular point? Or let's say I give you the length of this column. So when you have this manometer, how it usually looks is you have some, this is a graduated cylinder, so you'll have some markings on the top of this one. So based on that marking, you will be able to calculate. So let's say you'll only be able to calculate the length of this particular column. So let's say I give you the length to be L or something. So what will be the pressure? If I tell you the length is L, so what will be the pressure difference between the point here and a point here? So I have point A and then I have point B here. Let's say point A is close to this particular surface, and then L is this length. From, say, here to here. So what will be the pressure? Pressure difference between points A and B. So it's just the hydrostatic pressure that we discussed a while ago. So what will be the value? What will be the expression for that?
Sir, how can know that I will there as a
So you are saying at point B, how will I get hydrostatic pressure?
Yeah. How can you know the or this pressure there the manometer I can use this hydrostatic pressure?
So the reason for hydrostatic pressure is what? Is because of whatever fluid is sitting on top of that, right? So here if you are at point B,
Top to bottom.
yeah, so if you are at point B, you will definitely feel the weight of the fluid on top of you, right?
Yes, yes.
So that is what we are calling hydrostatic. So basically you feel it from all the directions. I'm just kind of simplifying it here.
What is the definition of the hydrostatic pressure, sir? Any fluid going from the top to bottom.
Hmm.
It's called the hydrostatic pressure.
No, not in that way. So it's like if you consider a fluid, so basically first there are two different scenarios. Hydrostatic is only dealing with the fluid that is not in motion. So whenever a fluid is not in motion, it's like some kind of some container or something. Then if you consider any point inside the fluid, that will experience a force because of the weight of the fluid on top of it, right? So it's like 10 people are sitting, like it's like the pyramids that we form. So if 5 people are there and top of them 3 people are there, on top of them another 5 people, something like that. So people standing on top of each other. Then whoever is at the bottom will feel the weight of everyone on the top. If you take any person who is somewhere in the middle, he will only feel the weight of people on top of him. He wouldn't care anything about the people on below him, right? So this is purely because of your gravity. Since your gravity is in downward direction. So in this scenario, what will happen? Even though there is this much fluid on top of this, but the gravity is acting vertically downwards. If gravity is acting downwards, then you will feel force only in the downward direction, not along the length of it. So though there is L length of fluid on top of you, basically that is not top of you, but at certain angle. So you have to accommodate for that angle and then calculate your hydrostatic pressure, right? So what will that be? So if L is the length of this and theta is the angle here, so what will be the pressure now? So what will be the effective height that you will be feeling the weight for? As I said, you should look in the direction of gravity. So whatever is the height that is in the direction of gravity is what you will feel. So if gravity is acting, if gravity is acting downwards in, say, in this particular direction, so what will be my net weight that I will be feeling if I am sitting at B? There are only two options. You have to choose either L cos theta or L sin theta. Which of them is right? You can just tell me that. So you have just two options.
F cos theta, F sin theta, sir. I think which component?
So F cos theta and F sin theta are the two components. So which one of them is along the gravity direction? So out of these two components, only one is affecting one. So which one is it? Cos theta component or the sin theta component? Which one is along the gravity direction?
Yes, sir. Yes, sir. F cos theta.
F or L? So you are referring to L, right? So I am basically asking about L.
L cos theta.
So L cos theta will be along which direction? X direction. So weight will be along which direction?
Y direction.
Like along the y direction, right? So you should be taking the component along y direction. So which component is along y?
L sin theta.
Yes, it's L sin theta. So like previously the formula is rho g h. So instead of h you will be having L sin theta.
Yeah. Yes.
Okay.
And so the L theta is 90 degrees. So I can use the sin.
Yes.
90 degrees equal to 1. Yes.
Theta equal to 90 and that will come back to your original formula.
Yes.
So now the next part of the question is, do you think will this particular thing have any advantage over a YouTube manometer? Like why do I have to do all this inclination and stuff? Will it provide me any advantage or it is just
Whether this manometer or whether it will be over the 2 manometer.
both are measuring pressure? Both are measuring pressure only.
More than?
Both of these things are measuring pressure. So will I get any advantage by using this inclined manometer? Okay, Okay, before even asking about it, so let's try to kind of dissect the question. So what do you mean by advantage? So how do you say one instrument is advantageous over the other? So what are the metrics on which you will compare such things? So I just want to set the direction so that you will think in the right direction. So when I say that one manometer is better than another manometer or something like that, what is it that I am comparing between these two things? Both are measuring pressure only, right? So I should compare them based on something. So what is it that I will compare them with? Can I say accuracy, cost, something like that? So when you want to answer questions like this, you need to come up with some metric that you can use to compare these two different manometers which are measuring the same quantity. So is there anything else, something like those things that you can come up with? Accuracy is one, cost is something else, ease of operation or ease of use, let's put it simply, ease of use. Anything else more important? I'll just put accuracy, precision, all these things in only one bracket. So let's say sensitivity. I don't know if you have come across this. So you know what is sensitivity of an instrument? So sensitivity of an instrument is like if you want to measure something. So let's say if you want to it's if you can compare it with the least count of whatever you kind of read before. So if you want to measure something in kilometers, then you would require something in that particular order, or maybe that's not a right example. So to put it simply, sensitivity is like if something changes by 1 unit, how much will your instrument show that change? So the change in output by change in input. Per unit change in input, what will be the unit change in the output indicated by that particular instrument is what we are calling sensitivity. Ideally you would require like the instrument to be very sensitive so that even the small changes in the input value, for example, if the pressure at point B is changed by 0.1 bar, then your instrument height also should change by certain value. And if you want to compare this particular sensitivity of a YouTube manometer versus this inclined manometer, do you think will there be any change? So if there is a unit or let's say if there is 0.1 bar difference in pressure, then will it give rise to the same value of change in the output? Output is basically this particular length, the graduations that you see on this cylinder. So will it be same for both the YouTube manometer and this particular inclined manometer? So you already have the formula. So maybe I'm not sure if you have introduced this concept before, so I just want to show you that. So sensitivity is basically change in output per unit change in input. So the output in this case is say H or L, whatever you consider. So that will be in this case, okay, I've used a different notation. I've used H here instead of L. So maybe I'll just for consistency, I'll just change this to H. So output is my change in H divided by change in pressure is given by 1 by sin theta. So if you see like if you are using an inclined manometer, then you are having much higher sensitivity than using a YouTube manometer. So for the same graduation scale, let's say if your graduation scale is in the order of millimeter, then you will be able to capture more millimeters with an inclined manometer than the normal one. So that is the only advantage with this one. Okay, I'm not sure if you are introduced this concept, so we'll not go into the other questions of this. So we'll go to the next. Okay, is it clear or are there any questions?
Clear, sir.
Clear. Okay. So let's go to the next problem. Next one is again a straightforward one. You just need to substitute the equation and then you'll be able to calculate this. So there is some manometer which is attached to a tank of gas. The gas pressure is already given to you as 104 kilopascal. Inside the manometer, the liquid is mercury, the density is given to you, and acceleration due to gravity is provided. And it is saying that the atmospheric pressure is 101.33 kilopascal. So the first part, okay, instead of solving the first part, you can directly solve the second. What is the gauge pressure in this case? We have already defined what gauge pressure is. So there is a manometer, one end is inside the tank and other end is exposed to atmosphere. So what will be the gauge pressure?
Sir, I will come back some later because something will need to work, sir.
Okay. Since the session is already being recorded, I think I'll keep going on. So the gauge pressure is defined as the pressure difference between inside the tank and the outside atmosphere. So inside tank pressure is already given as 104 and the outside atmosphere pressure is also given. So the gauge pressure is just the difference of these two. As we discussed before, if suppose the pressure here instead of 104, if it was 94 kilopascal, so if the pressure inside is actually lower than the atmospheric pressure, then gauge pressure can actually be negative. So instead of showing a negative value, you can also write it as a positive value and write vacuum before it. So you can also say a vacuum pressure of 2 kilopascal, a vacuum of 2 kilopascal means the pressure inside is actually less than atmospheric pressure by 2 kilopascal. So now once you know the gauge pressure, the difference in the mercury levels is basically you equate this gauge pressure with the rho GH formula that we have before. We already know rho G, so we should be able to calculate the height directly from there. It's just a straightforward calculation, so I'm not spending more time on it. You have the pressures, you just calculate the difference. Once you have the difference, H is given by gauge pressure divided by rho G. So that is giving some value of around 200 mm. Sorry, 20 mm. The next one is something that deals with properties and states. So this is also more of a straightforward one. So maybe I'll give you can go through it and kind of tell me the answer in say a couple of minutes, and then after that we'll discuss. Okay, I think you have solved this. So it is a closed system. The mass of the gas is fixed at say 5 kilogram, and it undergoes certain process, and the process is also the equation is also given as PV to the power 1.3 equal to constant, and the initial state is also given. Initial pressure and initial volume, specific volume are provided, and the final pressure is given. Now your initial state is there and final state you have to fix. So you have to go from this initial state to the final state. The path is already fixed by the equation PV to the power 1.3. So once you know the equation and the initial point, like you know the path and you know the initial point, so you should be able to calculate the final point. So first part asks you to determine the final volume and plot the process on a graph. So even before that, how do I calculate volume? Volume is basically The specific volume is volume divided by mass, so you can calculate volume by multiplying, like specific volume is meter cube per kg. So if you multiply this with mass, so you'll be able to calculate the total volume. It is also mentioned that it is a closed system, which means the mass remains constant. So 5 kg mass is going to remain constant. So using, first you calculate V2 here. Once you calculate the specific volume at the final state, you multiply that with the mass, so you'll be able to calculate the final volume. So initial mass is given, so final volume, you can directly use this relation, you will get the specific volume. You already know the mass, so you multiply with that with the initial mass, and then you get the final volume. And to plot it on the to plot it on the graph, we need to know the equation. So here it is just says PV to the PV to the power 1.3 is constant, so I need to determine the value of constant. So I can use any state, either initial state or the final state. So let's say I'll use the initial state, P1 and V1, I'll just substitute that, I'll get a constant, and then I'll plot the plot. So the plot goes something like this. So the x-axis is your specific volume and y-axis is your pressure. Now I haven't shown it here, but ideally you should actually show this with an arrow indicating the direction in which the process is happening also, and you have to label x and y axis appropriately. Now I have some discussion problems. So I encourage you to kind of interact and then be able to discuss these questions so that you can have better grasp on the concepts. So maybe I'll wait for like 2-3 minutes so you can go frame your answer, and then we'll start the discussion. I hope you have gone through the question. So basically there is a motor, there is a battery, and then there is some mass attached to it, to the shaft of the motor. So once the battery gives the power, the shaft rotates, and because of the torsion, because of the tension in the string, as it gets rotating, so the mass will actually raise upwards. That is the intent of this. So now we'll assume, like, we can consider different cases. So let's say I'll only consider the battery as my system. So if I draw a boundary over the battery, so the only interactions are, so that particular boundary is in contact with what? So it is cutting two things. Let's say it is not cutting the battery, but it is just outside the battery, then it will, what will cross the boundary? One is the air, and second is these wires that are crossing from it. Yeah, hi. So we just solved a couple of little problems just before you left, just after you left. So those are just straightforward problems. You can go through the recorded session later, and anyways I'll upload this, so we'll go ahead to the next problem. I think that is fine, right?
Okay, sir.
Yeah. So you can go through the question. So this is basically, you have a motor here which is connected to a battery, and because of this power the shaft rotates and the mass kinds of moves up. So this is straightforward. Now all I want you to do is consider different scenarios, different components as your systems, and tell me what is happening, like what is happening at the boundary, what is a heat interaction, what is a work interaction. Maybe to start with, let's say I'll give you an example of what I'm expecting from you. So let's say if I want to consider a system boundary around this battery. So the boundary is cutting, like it is not touching the battery, but it is cutting the air surrounding the battery, and then it is also cutting these wires. So what is crossing my boundary? Whatever electrons that are flowing from the battery to the motor, they are going out and then they are coming in. So those electrons is something that is moving across the boundary. So will it be heat or will it be work? Second, there is air that is moving across the boundary also. The air will come in contact with the battery and then it will again go out of the boundary. So these are the only two interactions that are happening at the boundary. So can I consider the interaction across the terminals as heat or work?
How can I understand these types of questions very easily, sir? Because sometimes I see these types of questions and like regret that I think and about the way these question will be described. So how can I solve this design? I think that giving according to question.
Okay, let's kind of dissect the question again. So before even trying to solve, the first thing is you need to decide your boundary. So you need to draw the boundary. After drawing the boundary, you need to have an idea of what is heat and what is work. So what is the difference between these two things? So what is the definition of work? So work is something that could be converted into raising of a weight. If you can do that, then you will consider that as a work. Let's take the example here. So let us start simply with the motor first. That is the easiest one. So if you consider a boundary around the motor, so there are two things happening. One is the input. At the input side, let's say at the left hand side you have input from the battery. On the right hand side a shaft is connected and that is rotating. So now, and then there is other interaction, that is air is crossing this boundary and touching the motor also. That is the third interaction. These are the only three things. So first you have to identify what all things are crossing the boundary. That is done. Next thing is at each of these, let's say I have identified these three things. The next thing is I need to understand where heat is happening, where work is happening. Now first consider this shaft. So what is happening at the shaft? As the shaft is rotating, the particular thread whatever is attached to it will roll itself onto the shaft and then the mass will raise. So the definition of work is that. So if you do anything that can be converted into raising of a weight, you consider that as work. This is a very straightforward form of it. The shaft is rotating and then the mass is raising, which means this is work. If mass is raising upwards, then it is work done by the system. If mass is going downwards, that is work done on the system. Now consider the left hand side of it. These are just the battery terminals. So what is happening here? What is happening at the battery terminals? Some electrons are coming and moving out of it. So let's say one of them is a positive terminal and another one is a negative terminal. So electrons will come from one and leave from the other part. So is it doing any work? Or can it be connected to something to get work out of it? So instead of connecting directly to the motor, you can connect these terminals to something else, another motor, and then connect to the mass, and then the mass will again raise. Or put it in a reverse way. So motor is actually doing work, motor is doing work on the mass, but then battery is doing work on the motor. Like the electrons that are coming here and moving out of this is what is doing work inside the motor, that is causing this mass to raise. So as long as you have, sorry?
How much question here, sir?
How much?
How much questions solved here, scientific assignment?
Every week you have only 10 questions, right? So I hope you are already submitting those assignments, right?
I didn't attend the assignment one.
Okay, the deadline is 7th, I guess. So you can submit by 7th.
No, sir. I am asking what the here, how much is question? Yes,
During the session? Usually I keep it to around 10 questions. So, but I want these sessions to be more interactive, so you can ask your questions and we can discuss over them. Like the main objective of this session is to clarify any of the doubts that you have. If we have time left, then we will solve some problems also. But now that not many of you are asking any questions, so I'm just taking some problems and kind of trying to have some discussion. So is this part clear? For the motor, is it clear? Maybe I should ask the next part, then I'll understand if you understood it correctly or not. Let's say if I consider boundary like this, I'll consider everything as my boundary, everything as my system. So what are the interactions that are happening out of the system? So whatever is happening inside of this, can I raise a weight because of whatever is happening inside? So again, like just like before, what is happening at the boundaries is basically some air might be moving here and there. That's the only thing that is happening at the boundaries. As long as your mass that is inside here stays inside the boundary, nothing is going outside the boundary from these components. So all you have is some heat interactions, but there are no work interactions. Anything that is happening inside the system is not giving you some energy to actually that can be converted to work. So basically that can be converted to raising of a mass, unlike the previous case. So previous, when you consider the motor, so whatever is happening inside the boundary is causing this mass to raise. That is something that is not happening here, because whatever is happening inside the motor is raising the mass, but that is also within the system only. That is not crossing the system boundary. So this is not work. So no work is done at these system boundaries. Is this clear? I hope this is clear. Actually maybe it will get better if you go through week 3 also. Then maybe we'll discuss this in next week also. Next couple of weeks we'll be discussing on heat and work. So it will get clearer and clearer as you go. This is a very straightforward problem. It's just kind of an ice-breaking one, so you can quickly solve it and you can tell me the answers. So there are 3 processes and then there is cycle that is happening. So the first process is PV equal to constant, which is your isothermal process. The second one is a constant pressure one, and the third one is a constant volume process. Whether this process is feasible or not, these are the questions that we'll address in upcoming sessions, not now. For now, just it's about calculating these properties, just about using these equations and then calculating the properties. That's it. So you know initial pressure? Yes.
Sir, can you explain us what is the cyclic process and forcing process, state process? Can you please this types of questions? I don't know these.
Yeah, we will discuss them in upcoming sessions also. For now, I'll explain you what a cyclic process is, but then we'll discuss quasi-equilibrium and other stuff a little later, next week maybe, probably. Yeah, it is discussed in next week lectures, so we'll discuss in next session. To put it simply, a thermodynamic cycle is basically you start from a certain point, you undergo certain processes and you come back to the same state. So wherever you start, you do something and again come back to the same point. This is what we are calling cycle. So in order to have a cycle, you should have at least minimum 2 different scenarios, like you should go to somewhere and you should come back. So here, in this particular case, your next question is on quasi-equilibrium, right? That maybe it's better, we'll discuss it in next session. So I guess cycle is straightforward. Now in this question, so initially you start with some pressure volume and then you go to a different pressure, and from there you take another process. So it's like going from your house to your office to a certain particular road. So that particular road is an isothermal process that is given here. And once you reach your office, from there you go to say some cafe or something. That is your next process, 2 to 3. And from cafe you directly reach back to your home through a different road. So there are 3 roads. One is isothermal process, the next one is a constant pressure, the third one is your constant volume. So what I am telling you is giving your coordinates. So I am telling you, you are starting from your house, so you know the initial coordinates P1 and V1, and I know that you will be reaching your office, and I know the road in which you are going, so I should be able to calculate what is my final state. So in this case you have P1 V1 equal to P2 V2, you have only one unknown P2, and then you have all these three known, so you can directly solve and get the value of P2. Second scenario, you know P2 and V2, and it is a constant pressure process, so P3 equal to P2, and then you can directly calculate V3 is also given, so you should be able to do that. The last process is a constant volume process, and you don't even have to solve this. So initially you went from point 1 to you went to this particular case. The next you went through a constant pressure process. After that it is a constant volume process, but you don't have to solve this because you know it is a cyclic process. The final state should be same as your initial state, so you should reach the point where you started from. So you don't have to calculate separately for that.
Repeat again, sir.
So in the question it tells you that it's a thermodynamic cycle, which means after solving one, like from 1 to 2, you went from point this one point to isothermally you went to here. So and then you have to go to isobaric, is essentially constant pressure. So you went uphill here. Now you don't even have to solve this problem. You know that you have to reach this particular stage from this particular state. So you don't have to solve this separately. You already know this pressure and volume initially. Like the initial pressure and volume are already given to you. So you don't have to solve for it separately. That is just because you know that it is a cyclic process. Is this clear? I guess it's clear. This is again more of a discussion. The last two problems are more of discussion ones. So in all of the above problems, or let's consider whenever we have this mercury column, we discuss that there is something called a hydrostatic pressure. So whenever there is some liquid column or some fluid on top of your head, you will feel the weight of that fluid on you. But whenever we are solving this piston cylinder problem, let's say this problem, when we are solving this problem, why didn't we consider the hydrostatic pressure inside this one? We assume that the pressure is constant throughout this particular volume. So why is that? Why are we not considering the hydrostatic pressure? Did we do something wrong, or is it okay to do that? So first, is the question clear?
Yes, sir.
Yeah. So why do you think we are not considering it? So why are we not considering the hydrostatic pressure in case of air? So
Actually, sir, this types of read this story, this theory, so that's where I have not answered the question.
okay, let me kind of help you on that. So whatever we discussed. So if you want to answer such questions, so where do you start from? So the question asks you like pressure variation along with elevation. So what is the formula for what is the formula that relates your pressure with elevation?
Sir, top V to bottom V, sir.
So what is the equation? Equation for relating pressure and elevation.
I don't know.
In case of hydrostatic pressure, what was the equation? Right? This was what we yeah. So this is the formula we have. So now we are saying that you are neglecting this one. So when can you neglect this equation? Either your h should be so small or your rho should be so small. Only in those two cases you can neglect this one, right? So with in case of air, what happens is your rho is very small. Rho is close to 1 1 gram per cc, so loud. Sorry, not even 1 gram per cc, 1 kg per meter cube, which is very small. If you consider mercury, that is around 13.59 gram per cc, so basically 13.59 into 1000 kg per meter cube. So it's like, if you consider water, even water is like 1000 times more heavier than air. So in water, mercury, basically in all liquids which have higher densities, this becomes important. But when you are solving problems with air and other gases whose densities are very low, this particular delta P, maybe I should write delta P here, so instead of this delta P, because of your hydrostatic pressure, is very small and you can neglect it. That's why we are assuming pressure to be uniform, even though there is certain height inside that.
Yeah.
Okay. I just made some little calculations to show you how much variation it is. So if you just calculated STP conditions, or let's say not STP, it's at 300 in Kelvin, you get density to be around 1.16 kg per meter cube. And if you substitute that, in order to give you at least 1% variation, the height should be close to around 87 meters.
Sir, how can taken, sir, from this the pressure bottom equal to P static plus pH?
Pressure.
So P pressure bottom equal to P static plus P rho gh.
Yeah. P static is essentially what I want to say here is P whatever is on the top. Let's say top here, to avoid any confusion.
Actually, I think so. Whenever I think about the bottom, I can add the top and add the rho gh.
Yes. So at bottom is top plus rho gh.
And according to question asking about Sati, what is the pressure top bottom? How can it formula is like P bottom minus rho gh or plus rho gh?
No, I didn't get your question.
Actually, here is asking about the P bottom, sir. And whenever question asking about the P top, what is the use of formula for like P bottom minus rho gh or plus rho gh?
No, but if I am asking question about P top, so which means you already know the value of P bottom. So usually the case will be like this. So the top of the container will be exposed to some atmosphere, or it will be exposed to some pipeline or something like that. So P top will be equal to that pressure. So P top will be, if it is open to atmosphere, P top will be atmospheric pressure. If it is open to a supply line, it will be equal to the supply line pressure. So it will be always asking on the bottom pressure. So if somehow you are, as if you saying like there is a scenario where the bottom pressure is somehow known and you are asked to find a top pressure, like in case of a manometer, then you have to do minus rho gh. If the formula remains the same, all you have to do is this bottom top is essentially with respect to gravity.
So how can I observe that, sir, here is taking minus rho gh?
So that was what I am trying to say. You should look in the direction of gravity. Along the direction of gravity, your pressure will keep on increasing. So from top to bottom, so top to bottom is the gravity direction. So from top to bottom, your gravity is moving. So pressure at the bottom should be higher than pressure at the top. So P bottom is P top plus rho gh. Okay.
Whenever the gravity force upward, how can take the minus rho gh?
Yes. So it's basically again gravity direction, pressure should increase. If it is in the reverse direction, then you have to put a minus. That's it. Okay. The last question is again more of a discussion oriented one. So this is just to kind of show you where you can use this particular course. So let's say you have a old fashioned bicycle tire that you have, instead of a compressor pump that we are using nowadays, you can also use the regular ones, manual ones, where you have to push the piston to actually compress the air inside your bicycle tire. So what are the processes involved over there? So what is my system, what is my surrounding, what is my system boundary, things like that. I just want you to think on this, and then maybe you can think for a 5 minutes, and then we will discuss. So you have a tire and then you are pumping air inside it. So I just want to understand this phenomenon. I want to understand what is pressure, what is volume, what is temperature, and things like that. So what will be my system? Where will I consider my boundary? And what are the processes? Is it isothermal, adiabatic, constant pressure, constant volume? What is it that is happening there? So how do you answer such questions? So maybe you can start with the schematic first, something where you can understand like this. I already gave you what is this, but okay, that's fine. So I kind of made very simplistic things, like you do not have a square tire and just assume that it is a square tire, and then this is your piston, so I am applying a force on it and this is compressing. So as it compresses, air moves from here to here. It's a very simple case. So now my initial state will be given by initial pressure, volume, mass and temperature. And my final state will be given by some P2, V2, M2 and T2. That is fine. So first question, can I consider this entire thing to be my system? Yes or no? I think you can see the answer directly. I have already drawn the boundary, so you can consider that as your system. If only if there are no leakages, so there is no mass that is escaping from them, then you can consider that as a system. So if I somehow know the final volume, okay, even before that, so what are the processes happening here? What is happening inside this one? If I consider only this air as my system and I close this valve, what is happening here? What type of process is that? Okay, so basically we are applying some force on the top and the piston is moving downwards, and let's say this particular valve here is closed. So some compression is happening. Can I consider that compression to be a constant pressure process? Obviously I cannot consider it as constant volume because it is getting compressed. If the valve is closed, can I consider that to be a constant pressure process? So is the question clear? So this is your pump. You are just pushing the piston downwards, so it is getting compressed. So obviously the volume is decreasing as you compress. If this particular valve is open, then when you compress this, air will flow from here to here, and the flow happens till the pressure is same in both of these containers. So I am considering the entire thing as my system, so that the total mass is constant. So what is happening to my pressure if the valve is closed? Now let's say the valve is closed. So the valve is closed and then you push this piston downwards, so this compress. So what is happening to the pressure and temperature here? Usually for these kinds of processes, whenever you do things very fast, so if you had pushed this piston very fast versus pushing the piston very slowly. So if you push the piston very fast, then what happens is at the boundary, because you are pushing it very fast, the whatever medium is inside will not have sufficient time to exchange heat with the surroundings. So what is if there is no heat exchange with the surroundings, you call it to be an adiabatic process. So only if you do it fast, you call it an adiabatic process. So how fast should it be? So what determines how fast should be considered as adiabatic? Or maybe I should ask, how fast is actually fast? if this is completely insulated, so basically adiabatic is some assumption that most often these things might not be given in the question directly, but then you have to come to these conclusions. So either the question will tell you that it is insulated, which is a very straightforward one. So if it is insulated, then it means there is no heat interaction with the surroundings. So that is a straightforward case. And then comes the scenarios like this, where the process happens so fast that even though your Q in terms of watts might be too high, but then the amount of time that the process is taking is so low that the energy interaction Q times delta T will actually be very low. So net heat interaction will be considered zero, and even in those scenarios, even though the piston is not actually insulated, you can consider that to be an adiabatic process. These are things that you might come across in some questions where they directly don't provide it, but then you have to, they will somewhere say that it is a very fast process or something like that. And then let's say you can also move the piston very slowly. If the piston is moved very slowly, then the fluid inside will have sufficient time to actually readjust itself and then reach some common temperature or something like that. We will discuss on what is quasi-equilibrium, things like that in next week maybe, not now. We also don't have sufficient time for that. So in this case, we already have what is the initial pressure, initial temperature and other stuff. So if there are no leakages, your mass is also constant. So we can measure what is the final volume. In this case, we can measure what is the final volume. We can assume that the tire volume is constant. If the tire volume is constant, all we need to know is the only two unknowns. So I know the final volume, I know what is the total mass M2. I just have two unknowns, pressure and temperature. So how do I get that? That is where I have the assumption that we have taken comes into picture. So you assume that this particular process is an adiabatic process. So you know the relation in terms of the state variables. So in terms of pressure and volume, it is PV power gamma equal to constant. This, to be more specific, this should be used only in case of isentropic process, which this might not be a very good assumption for that because of some okay, we'll not go into that. But for now, let's assume that you know the equation for the process, and that is in this particular way. You can also use the ideal gas equation and then write it in terms of temperature, this one. So that will give you something like Tv power gamma minus 1 equal to constant, and you can substitute it back to find your appropriate equations. So I've just defined a new variable R here, so that will be V1 by V2, so you get your final pressure in terms of it. The question now is when you want to inflate your tire, so let's say you want to have a gauge pressure of around 3 bar. Might not be a real value, but then let's say you want to have a gauge pressure of 3 bar in your tire. Then when you are inflating the tire, you should actually not inflate it till 3 bar, you should actually inflate it to much higher value. That's because when this is compressing, your temperature here will increase, so the pressure here will be higher. So when this high temperature gas goes inside your tire, the internal temperature will also be higher. So the tire will be at a higher temperature than the ambient. So what will happen because of that is this tire will gradually lose heat to the ambient. So then the tire can be considered as a constant volume. So when it is exposed to a cool environment, so it loses heat to the ambient. So then the temperature will drop, and because it is a constant volume process and mass is also not changing, your pressure will also drop. So if you want it at 3 bar, you should actually increase it to a little higher value than that. So if you, let's say if it is at 3.5 bar, when filling the tire, you fill it at 3.5. So when it is exposed to ambient, then eventually it will come to 3 bar. So this is just the equation relating between what is your required pressure and what is the pressure at which you have to pump. That depends on your compression ratio. Basically that depends on your ambient temperature, and it also depends on the temperature. Basically this R is some property that is determined by your compression ratio, that is the ratio of this volume to the final volume. So depending on the pump, this will change. Is this clear, or are there any queries in this? Just to summarize, the main points that we have to take away from this particular question are: 1, whenever you say, instead of insulating or something like that, whenever you say a process is happening very fast, then it means that the process doesn't have enough time to interact with the surroundings, and you can consider the heat interaction to be zero, and that process can be considered as adiabatic. This is the main takeaway that I want you to take from this particular problem. Are there any questions? So if there are no further questions, I think we can conclude the session for today. Or if you have any questions, we have about another 15 minutes, so we can discuss them. So I'll keep the session open for discussion. If there are no further questions, I think we can end the session for today. Thank you for joining, and then we'll meet next week. So we'll discuss on what quasi-equilibrium is, and then we'll also solve problems related to first law of thermodynamics, so relating to basic concepts on heat and work. So please go through the lecture videos as well. If you have any queries, you either post in the discussion forum or we can discuss during the sessions. Thanks for joining. So I'll conclude the call for today.